Hello, my name is Pologruto. For my project, I tried to predict sleep disorders from health indicators. So this project examines two different sleeping disorders, sleep apnea and insomnia, and it'll use data from a data set called Sleep Health and Lifestyle, which I found on Kaggle. The main question I want to research is how well a multinomial logistic regression model can classify whether a patient has no sleep disorder, insomnia, or sleep apnea based on variables. Within that, I'll look at which variables contribute most strongly to predicting sleep disorder, how well the model performs at predicting the sleep disorder on new and unseen data, and if certain variables are more indicative of one sleep disorder versus another. For example, like high stress is more telling of insomnia than sleep apnea. And then for the background and significance, I'm a college student. We all know how important sleep can be on your personal health. There's many things that go into what kind of sleep you get, like stress levels, work schedules, physical health. So I just wanted to understand what factors actually influence it and which factors can predict sleeping disorders. So for knowing the data, I'll look more into the specific variables later. There's 374 observations in this data set and 12 prediction variables. So for some of my exploratory data analysis, I first want to look at the distribution of the diagnoses in the data set. As you can see, most people in the data set have no sleeping disorder. However, there's a healthy amount of patients with insomnia and sleep apnea. And then I wanted to compare sleep disorder to different variables. So first I saw the distribution of sleep durations by the 3 different sleeping disorders. As you can see, people with no sleeping disorder have higher median. Insomnia, of course, is going to be the lowest. Another one I wanted to look at is stress level versus sleep disorder. Those with insomnia and sleep apnea have higher median stress levels than people without sleeping disorders. And then I want to look at sleep disorder by BMI. So this shows the proportion of the BMI categories in every sleep disorder category. It's interesting, as you can see, in no sleeping disorders, most people fall within the normal/healthy BMI category, and there's a few overweights. But in the insomnia and sleep apnea ones, there is a very high percentage of overweight and obese people. And then finally, I want to do a pairwise plot. So this is going to create scatter plots for different predictor variables in the data. I just wanted to see if any predictor variables had linear relationships with each other. Since I'm using a multinomial logistic regression, you have to look out for multicollinearity. I noticed that like sleep duration and physical activity level kind of do. Heart rate, daily steps will also have a negative linear relationship, but that would be taking into effect when I'm doing my assumptions for my logistic model. So the first thing I did was split the. So I chose to do a multinomial logistic regression model because sleep disorder has 2 sleeping disorders and the no sleeping disorder. So a regular logistic can only determine between 2 categories. This one has 3. So for using R, I use the NNet package for the multinomial function. I decided to use a 70% training and testing split. I also experimented with the 80% training. However, I wanted a larger testing group to just have more predictions. And then to clean the data, it's very simple. There's no NA values. I changed some variables into factors, and I also split blood pressure into the 2 different numbers. So between 120/80, I split it into 120 and 80. And then looking at my multinomial logistic model, first I split the test and training data up. I wanted to see how many of each sleeping disorders were in the training and testing. The main thing I was looking at was just making sure there's enough insomnia and sleep apnea cases in the testing data set, just so the model had a chance to predict those. And then I fit the model using every single other predictor variable other than sleep disorder in the data. So for goodness of fit, I did a likelihood ratio, which is a null model versus the model I fit, has an extremely low p-value, so that means it significantly improved the fit over the null value. I used a McFadden R-squared value, so a traditional R-squared value does not work for logistic regression models, so we have to use a pseudo value. McFadden R-squared value is 0.730. Anything above 0.4 is considered extremely high, so this indicates the predictors explain a large portion of the variation. Then going into performance on the new data, this is a confusion matrix. It predicts it with very high accuracy. It correctly classified 61 out of It had an accuracy of 91% with an accuracy p-value of 0 and a Nehmer p-value of 0.0719. That's not a significant value. However, when you're looking at that p-value, you want it to be insignificant because it shows that there's no strong evidence that the prediction that when it makes a mistake predicting, it biases a certain class. And then for my second model, I wanted to select the variables that are significant to both the insomnia and sleep apnea in the first model. I also wanted to make this model much simpler since in the last model I used every single variable. So I decided to go with sleep duration, quality of sleep, stress level, BMI, heart rate, and daily steps. And these are just the p-values of the first model. As you can see, age was insignificant for insomnia. And then the goodness about my second model, the new McFadden value was 0.545. It's still extremely strong. I also wanted to look at all the p-values for every predictor in this one. So as you can see, everything was significant except for sleep duration was not significant for predicting insomnia. And then for this one, I calculated some of the odds ratios. So the odds ratios tells us how a 1 unit change in predictor will affect the odds of being in a certain group. So for example, being obese raises the odds of insomnia by 158,000% in this data set, which is pretty extreme, and I'll talk about that more later. But an easy example was each increase in heart rate lowers the odds of insomnia because its log odds ratios is less than 1. And the performance of this one is very similar to the first one. It has an accuracy of 91% and also this very strong CAP score. It has an insignificant Nehmer p-value. Performs well across all three categories. As you can see with these statistics here. As you can see, in these models, they predict different classes with different accuracy. So on the second model, it predicts the sleep apnea class the best, better than insomnia and no sleeping disorder, as you can see from the bounce accuracy. And in the first model, it predicts no sleeping disorder, or it also predicts sleep apnea the best. So, choosing between the two models, they both perform nearly identically. Their overall metrics are almost exactly the same. They have slightly different Nehmer p-values. They're both insignificant, so they show the same exact thing. The first model performs slightly better at predicting no sleeping disorder and insomnia, while the second performs better at sleep apnea. They do have comparable McFadden R-squared values. However, the first one has a higher R-squared values. I do believe this could be due to it just having more predictors and not inflating the R-squared value. But both models are very accurate, and there's really no wrong answer to which one to go to. For this project, I just selected the first model since it has a higher pseudo R-squared value and it performs better on 2 out of 3 of the classes. And then using that model, I interpreted insomnia versus none. So several predictors show strong associations with the odds of being classified in insomnia. Being a female increases the odds by 3-fold. Each 1 year stress level goes up. It increases the odds by 1.47% of having insomnia. So that shows that emotional strain could lead to it. In contrast, like sleep duration and sleep quality negatively affect your chance of having insomnia. So the longer you sleep and the better quality of sleep you have, the less likely chance of getting insomnia you have. This makes, I think, reasonable sense. And then BMI plays one of the biggest major roles. So being obese is associated with having extremely high odds of insomnia relative to just a healthy BMI, making one of the most influential predictors. But the strongest signals for insomnia involve like sleep duration, sleep quality, and BMI. And then for sleep apnea versus not, there's a different pattern that emerges. So being female actually dramatically lowers the odds of sleep apnea. Of course, getting older increases your odds of having sleep apnea. This is another thing that's consistent with many clinical research. Like when you get older, you have a higher chance of getting disease. But overall, the biggest predictors for sleep apnea were gender, age, BMI, sleep duration, and cardiovascular health. So some of the limitations I had for this project was my sample size just being too small. Should I just wrap it up, right? Okay.
All right.